Today, what we're going to look at are functions called logistic functions. We're coming up with logistic equations, and we see the word log in it, don't we? All right. And we also see we have one form where we have e to the negative kt, and another form where we have b to the x. That's just about like our two other methods of modeling. Yeah, a times b to the x. Yeah, and then we had the other one that was e to the negative kt. And hopefully we discovered in our lab yesterday, our cooling corpse lab, that those could somewhat be interchangeable, couldn't it? Because all we were doing was writing one with the base of 2.7, which is what e is, right? 2.71828 blah, 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 forever. And the other one, we wrote in a different base. What was the base?
10 times
10?
0.7.
0.7, yeah, 7/10.
Yes.
Okay? So these are two different models, two different formulas we can use to model logistics equations. The first one is population with respect to time. So let's see if we can figure out what all of these things mean. M represents maximum growth, as large as it can get. A is a constant that we'll have to solve for. K is a constant that we'll have to solve for. And T is time. Now, if it's the second model, B is the base that is constant, and X is time. So, in both models, we have the same things going on. Okay, so these are our logistics equations. Now, logistics are interesting in the fact that we have a maximum growth. And so we're going to look at some of these equations, and it's just going to make sense to us that, oh, we couldn't go beyond that. So let's look at problem number 1. Okay, on a college campus of 5,000 students, one student returns from vacation with a contagious flu. The spread of the virus is modeled by this equation. Well, now, doesn't it make sense that the maximum growth would be 5,000? That's how many students we have. The number that can get sick is the number that we have. No more than that. So does that make sense that that's our maximum growth? All right. And Y represents the total number of students that are infected after T days. The college will cancel classes when 40% or more of the students are ill. So they gave us the entire function here. And so all we're going to have to do is manipulate things. How many students are infected after 5 days? So what do we plug 5 in for? T. So punch this into your calculator. 5,000 divided by, parentheses, 1 plus 4,999 e to the negative 0.8 times 5. Point. Look at your paper. It's hard to read on my overhead. Okay, so we got that this is approximately 54.019. Okay, so how many students are actually sick?
55.
54. And one's starting to sniffle, aren't they? One is not showing complete signs, but they are on the way.
So they said.
They would not test as infected.
How did you get 54 students?
Did you pick the parentheses like I did?
Yes, but I got 0.054.
See what he did?
I did 5 instead of 5,000.
Ha! There we go.
Well done.
All right. Part B. After After how many days will the college cancel its classes? What do we do, guys? Take 40% of 5,000. What is that?
2,000.
2,000. So it's at 2,000 equal to 5,000 over 1 plus 4,999 e to negative 0.8t. Okay, so I got some issues I have to deal with here. And I'm going to need a little more space, so I'm going to give myself some more space.
By 1 over 5,000.
Well, this is in the denominator. Does it need to stay there? No. So I'm going to multiply both sides by that, and I get 2,000 times this. And this first time, I'm going to show all my work. Then after that, I probably won't. Okay, does everybody see what just happened?
Wait, where did you do this?
Okay, so I'm trying to solve for t, so I want it by itself. So wouldn't it be nice to get rid of this 2,000 instead of having to distribute and get really big numbers? How can we do that? Divide by the 2,000. So we get 1 plus 4,999 e to the negative 8/10 t is equal to 2.5.
Why would you not just add the 1 to the 4,999?
Well, because the 499 is being multiplied times this. So we have to follow order of operations. So the next thing we would do is just subtract the 1 to get it out of the way. So now we have 4,999 e to the negative 0.8t, and that equals 1.5. Now what would we do? Divide by. All right. All you people who did this on your quiz, should we, at this point, approximate this? No. Okay, good. And I'm just going to leave it as 1.5 over 4,908. We usually wouldn't leave a decimal in a fraction, but it's okay because we're not going there for the answer. The answer is going to be the approximation in just a minute.
Can you leave it up a little bit?
Oh, yeah. Okay, so I'm solving for t. It's an exponent. How do I solve for an exponent?
Multiply the size by 1.
Very good. I take the natural log of both sides. And when I do, that negative 0.8t comes out in front. Once again, I'm showing you all the steps, which I wouldn't normally do. Okay, what happens to natural log of e? It cancels. So we would divide by negative 0.8. All right, this is the exact answer, which doesn't really help us. So if you were to go to the dean and say, okay, we need to cancel school in ln of 1.5 divided by 4,999, all divided by negative 0.8.
Days.
10.
Days to the 10.
Okay, so we get 10.139. All right, so the dean of the school wakes up on the 10th day. Are we there yet? No. At the beginning of the 10th day, we're not there. So when will they cancel school? On the 11th day.
Well, they could
Does he want to prevent the spread of it then?
It just depends.
What if you're like living in dorms and you get up like half the people in the dorm and sick?
Okay, you try number 2. I think so.
Wait, how come you? Oh, because why are all the students still getting infected if 40% of the why would you go to like 11th day?
Because at the beginning of the 10th day, we haven't hit that number yet. We hit the number during the 10th day, and they'll cancel classes for the 11th day. Yes.
Where, in like the second equation, where do you get 9 from?
we're about to determine that.
Teach measurement.
Yeah, good. I like questions like that.
Do you round up or? No.
Excuse me.
There's one in the room. That's why there's only two of them. It's accurate.
I'm not in a science class. I don't want to hear this. Do you hear her?
Y'all are talking about the 0.29 of an animal?
She is.
Okay.
Well, that's just because Shelby was like, do I round up or down?
That's why I wanted to round up. But
No, that makes no sense.
apparently if you've got 0.019 of a student, you just have to kill it all.
You don't count. Yet.
So do we have to round for the month? We don't have to round for the months for B. Like to a whole number.
It depends on how you word it. You could say by the something month or during the something month. Depends on how you word it.
You always round this month, yeah, because you can't.
That's sunshine if y'all forgotten. That's what that is. Okay.
What's sunshine?
Oh wait, would you want us to round up the months?
It depends on how you word it. Okay. Did you get that there'd be 177 animals?
Yeah.
Okay. So here I got 13.27 months. So I could word it two different ways. I could say during the 13th month, it'll reach that. Or I could say by the 14th month. Either way, both of those are acceptable. I would be looking for this approximate answer also because I like the math. C, when will it exceed 900 animals? It'll exceed 900 during the 26th month or by the 27th.
Yes.
You could write it either way.
Within like 26 or within 27 months.
Okay, yeah, that makes. All right. Now, Claudia asked an interesting question a minute ago. Where does this number come from? Where does this number come from? Because when we looked back, we had the 1 plus, so we know where the 1 comes from. All right, let's think back at problem number 1. How many students came back sick?
One.
1. So if we plugged in 0 for time 0, what does this number need to be so that when I add it to 1 and divide 5,000 by that sum, I get 1? Does it make sense that it's 4,999? Okay, now let's look at the second scenario. Here we started off with 100. Okay, so at time 0, this should equal 100. So what do I divide 1,000 by so that the result is 100? Well, 1,000 divided by 10. 1 plus 9 is 10. Does that make sense where that number comes from? Okay, and that's going to help us in just a moment. All right, flip this over. I haven't written down these next 3 examples, but I have 3 more examples. Or you could write it wherever you want to, if you've already used the back. All right, so the first 2 examples are similar to problems that are on your homework. And then the next 3 will be similar to other problems. Okay, so we have 3 more examples, example 3, 4, and 5. Example 3 is going to be similar to number 1 on your homework. So, the initial value of a logistics function is 8, and the limit to growth is 56. The function passes through the point 114. Find an equation to model this situation. All right, so we have some choices here. And I think I'm going to choose this one. Y equals m times m divided by 1 plus a b to the x. Not the only way to do it, obviously, because we were given the other one. But I'm going to stick with this one for now. So what do we think m is in this scenario? 56. Because the limit to growth, the greatest we could reach is 56. And then it's 1 plus ab to the x. Okay. How did you know this was 6?
Because you have to divide 56 by 7 to get 8.
Good. 56 divided by 7 gives us the 8. So this 1 plus a, when we plug in 0, so for those of you that aren't following us, we want 8 here. And so we know that at time 0, that puts a 0 in here, so that goes away. So what would a have to be? 6. Okay, so now let's fill in that. Okay, so now I need to figure out b. How can I do that? Using the point. This is my x, this is my y, so 14 equals 56 over 1 plus 6 times b to the first. So I'm going to multiply by this and then divide by the 14 all in one step. Are you guys good with that? So I multiply this on both sides and then I divide it by the 14. Alright, so 56 divided by 14 is 4. So 6b equals 3 and b equals 1/2. So my final equation is y equals 56 over 1 plus 6 to the 1/2 to the x. Let's graph that on our graphing calculator. When you graph this on your graphing calculator, put this here. We know the y's need to go up to at least 56. So let's let our y min be like -10 and our y max be 60 and maybe count by 5s. And let's take a look and see what this graph will look like. It looks exponential, but do you see it levels off?
Yeah.
Okay. In reality, most things can't increase exponentially forever, can they? Like in this one, we're going to eat up all our resources. You know? This population can only continue to increase until the land can no longer support it. And then it's not going to increase anymore. It is science. Yeah. As Dr. Clark used to be here, he used to teach physics, and he retired last year, but he always, when he described science, he described it as a building. And the foundation, or the basement, he would call it, is mathematics. And then on top of that, you put science. Because if you don't understand the math, you can't do the science. Yes, sir?
When it hits the limiting factor, though, doesn't it normally like drop off?
It can, and ours aren't going to. Do you see what yours did? Yours looked something like this. It went up and then it went straight across, didn't it? And this right here is kind of like an asymptote, but we could actually hit it. Everybody could die.
Sounds like my thickest stuff.
There's a lot of death going on in this class right now, isn't there?
Yeah.
Simon, how you feeling today?
Great.
Good.
Not
Good.
tomorrow.
A little less normal than yesterday.
You don't get it?
So,
I think you failed.
Ezekiel.
That was harsh.
Huh?
Nothing.
Who died yesterday?
Chris.
Sellers.
It only makes
Sellers.
sense for me to kill myself.
Sellers died, but then who got caught?
Simon killed it.
Simon.
Shelby was the accomplice.
Maybe.
Yes.
Shelby
Was.
was a possible accomplice. All right.
I didn't comprehend it that way. I thought
This is how I told you to set your window.
I thought the person who left 10 minutes after I arrived. I don't remember who it was.
Goldberg, there's more than one possible accomplice.
Yeah.
I know. That's
Yeah,
what I
yeah,
thought
yeah. You
that.
could.
I like
All
that.
right. Example 4. The initial value of a logistics function is 8. The maximum growth is 120. The function passes through this point. So this one's similar to number 3 on the homework. Find an equation to model this situation. So it's also similar to the one we just did. There's just a slight hiccup in it. So let's see if you guys can find A for me. And then we'll talk about how to find B this time.
So we're using the same formula?
Yes.
Wait, what are we finding A?
You're finding A
In 14?
in example 4.
How do you decide which of the equations to use?
I always use the one that's easiest to manipulate. And in this case, it's this one.
Get off his desk, stand up here.
Huh. The initial population was supposed to be 24. This could cause a problem.
Number 4.
Makes all my answers wrong. Can y'all change this to 24 real quick? Well, I copied and pasted and didn't change everything. Do you guys ever do that?
No.
Yes, you do.
No.
No, never.
Yes, they do.
Just
So Luke, be
you,
quiet.
How do I
Is
get
that how we
to
talk?
change the root?
Yes, that's how I hear it. But no, that's not how you talk at all.
Wow.
All right.
So
I changed it to 24.
Did you get 4 for
wait,
A?
Miss Will.
I did.
Okay.
The part where you find
4?
A, that's like that'd be 120 divided by.
Okay, so you want to say 120 divided by 1 plus A is equal to 24. So basically you do 120 divided by 24 is equal to 1 plus A. if you're trying to solve it.
How do you?
Okay, so this gives us 5 equals 1 plus A, so A is 4. Alright, so now we have 1 plus 4 b to the x. But this time it's not 1 something, it's 3 something. So when we plug in the 30 now, we have a b cubed.
Trust me, I know.
Okay, so we're going to solve this. So we get 1 plus 4b cubed. So I'm multiplying that on both sides. And I'm going to go ahead and divide the 20 by the 30. So what's 120 divided by 30? 4. Okay, so I'm going to move the 1 over. Divide by the 4. Alright, so now I take the cubed root, or I could raise both sides to what power? 1/3 power. And that's the one I want to go for. Because when I look at this form, this will become 1/3 raised to the x. So it becomes x divided by 3. And that's our equation.
So really, it's just wait. Why is it x over 1/3 or x over 3?
Because it ends up being this right here is my b, and so when I plug it in right here, I get b. I get 3/4 to the 1/3 to the x, and when you raise a power to a power, you multiply, so it becomes 1 times x over 3.
Okay, so if it was like 2/3, would it be 2x over 3?
Yeah, if this were 2/3, it'd be 2x over 3. Very good. Okay, here's the last one. Given a graph, find the equation that models the function. Well, it looks like a logistics equation, doesn't it? This is where I hand drew it. This is where I did it on my calculator. All right, so what's my limit to growth, guys? 40. What is the initial amount? 4. So can I find A? What would A have to be? 9. Because I'd need 40 divided by 10. So A has to be 9. Alright? And look, they gave me another point. And then all you have to do is plug it in. So if I plug in the 10,
I know which one's A, which one's B.
I feel like the bell's about to ring, and I don't think I've given you your actual homework.
Yeah, the bell's gonna
Don't
ring.
worry about it.
Oh, here it is. Okay, I'm going to pass out the homework now, right after I end the video.